Alright, in this video we are going to extend our talk about equations of circles just a little bit. But first, I'm going to start with hopefully, what is a little quick review from algebra, completing the square. Right, so let's take a look at this quadratic equation and complete the square. To do that, we need to first move the constant term to the right side of the equation. Okay, so I'm going to add the 13 over, and we'll get x squared plus 4x equals 13. Now, to complete the square, we are going to add something to both sides of the equation. That something needs to be very specific. I'm going to add half of this b term squared. Okay, so this term right here, right, this is half of whatever the b term is, and then squared. So here, if I take 4 and take half of that, half of 4 is 2, and then 2 squared is 4. So I'm going to add 4 to both sides of the equation. Right? Now, the reason that I do that is now this becomes factorable in a very specific way. Okay, so let's factor this equation. If you remember from Algebra 1 from last year, x factoring, I take my b term and then take a times c, so 1 times 4, and that goes down here. So what I'm looking for is two numbers that multiply to 4 and add to 4. Okay, well, positive 2 and positive 2 multiply to 4 and add to 4. So what ends up happening is this will factor into x plus 2 times x plus 2. And that'll equal 17. Now, whenever we complete the square, these two factors will always be the same, which means I can actually rewrite this as just x plus 2 squared. Whenever I'm multiplying something by itself, I can write that as squared. Now, if we wanted to solve this equation for x, then we could take the square root of both sides and go from there to get x by itself. But for our purposes today, we're going to stop here. Okay? So we are going to use completing the square in our equations of circles here. I want to look at something like this. Okay? This is actually the equation of a circle. It looks pretty different from the form of the equation that we looked at earlier this week. Right? What I want to do is complete the square to make it look like what we talked about earlier. Okay? My goal is to make it look like this. X minus h squared plus y minus k squared equals r squared. Right? To do that, I'm going to have to complete the square twice. So whenever we have something like this, the first thing we want to do is organize the x's together, organize the y's together, and then move the constant over to the right side. So that's going to look something like this. Okay? I'm going to get my x's together. So x squared plus 18x. And then I know I'm going to be completing the square. So I'm going to go ahead and leave a blank here. Then I'm going to have plus, and I'm going to organize my y's. So plus y squared plus 14y. And I know I'm going to have to complete the square here as well. So I'm going to leave a blank here. And then I'm going to subtract this 105 over to the right side. Right? So I'm minus 105, minus 105. So I'm going to have equals negative 105. And now, since I'm going to be adding two things to the left side of the equation, I'm going to have to do the same thing to the right side. So I'm going to put two blanks over here. Right? So, if we think about what we just did in the warm-up example, I'm going to take half of my b value and square it. So half of 18 is 9. 9 squared is 81. So if I add that to the left side, I also have to add that to the right side, right? I'm going to do the same thing here. I'm going to take half of my b term, so half of 14 is 7, and 7 squared is 49. So I'm going to add that to both sides of the equation. So now we've created two different things that will factor into binomials squared. Now, in the warm-up, we went ahead and x-factored that, but there's actually a little shortcut. We don't have to go through the process of x-factoring every time. This will factor into x and then whatever half of the b term was. So here, half of b is 9. So without x factoring, I know that this, since I've created a perfect square trinomial, I know it's going to factor into x plus 9 squared. So let me make a few notes here. So this, remember, is half of b, or b divided by 2 squared. And then this value here is just b divided by 2. Okay, so same thing over here. If I just take half of my b term, I'm going to have y plus 7 squared. Right? And then equals, so negative 105 plus 81 plus 49 is me 25. So this is my equation of the circle. And now this looks like what we talked about in the last video. So now from this, I can get the center and the radius. Right? So my center is going to be at the point negative 9, negative 7. And my radius is the square root of 25, which is 5. Okay. Let's run through one more of those, right? Since these are a little bit longer. Well, actually, I guess before we do that, I do want to show you something on Desmos, okay? Now, I can just actually take this entire original equation and type it into Desmos, okay? If I type that original equation into Desmos, we can see exactly what we just figured out, that the center is at the point negative 9, negative 7, and the radius is 5. Okay, so you can use Desmos to check your work, right? But I am going to ask you guys to upload pictures of your work this time for when we do practice on these, because I do want you to practice going through this process, all right? Going through this algebraic process, but certainly use Desmos to check your work then and make sure that the equation of the circle that you got matches up. All right, so let's go through another example. All right, so the first thing we want to do is get our x's together. So x squared minus 10x, and then plus blank, and we'll have plus y squared minus 16y plus blank. And then I'm subtracting this 53 over to the other side. So I'll have equals negative 53 plus blank plus blank. So now let's complete the square. So I'm going to take half of b and square it. So half of negative 10 is negative 5, and negative 5 squared is positive 25. So I'm going to add 25 to both sides. And then come over here. Half of b is negative 8. Negative 8 squared is positive 64. So I'm adding 64 to both sides. So now we can complete the square. Remember the shortcut. All right, so this will just end up being x and then half of b. So half of negative 10 is negative 5. So this will be x minus 5 squared plus, here, if I take half of b, we'll have y minus 8 squared. And then over here, negative 53 plus 25 plus 64 is 36. So now the center of my circle is at 5, 8. Remember, we always take the opposite signs of whatever we have in here. And then my radius would be the square root of 36, which is 6. And again, we can check this on Desmos. Right? We can put in the original equation. Right? That circle will look something like this, right? Centered at 5, 8, and a radius of 1, 2, 3, 4, 5, 6. Right? So one other idea that I want to take a look at here is something like this. Okay, finding points of intersection between a circle and a line. Right? Now, this method will work to find points of intersection of any equations, okay, parabolas, lines, circles, and once you get into higher math, we'll do things like a sine graph or a hyperbola or an ellipse, all kinds of different things. Right? We can use substitution, which is something you've done in Algebra 1. Right? You've used substitution to solve systems of equations, but you did that with 2 lines. Now we're going to do it with a line and a circle. So, to use substitution, we need to solve one of the equations for one of the variables. This line is already solved for y. So what I'm going to do is take this 1/2 x and plug it in place of y in the other equation. So that's going to look like this. I'm going to have x squared plus 1/2 x squared equals 5. Okay, I'm just replacing that y with what I know y is equal to down here, 1/2 x. So now, to solve something like this, well, first I want to square 1/2 x. So remember, whenever we're squaring something like this, we need to square both pieces. I need to square the 1/2 and I need to square the x. So 1/2 squared, if I square 1, I get 1. If I square 2, I get 4. So 1/2 squared is 1/4, and then x squared is x squared. So now these are like terms, right? 1x squared plus 1/4 x squared. So 1 plus 1/4 would be 5/4, and you can use your calculator for that. So if I combine my like terms here, I actually get 5/4 x squared equals 5. So now I want to get rid of this 5/4. Well, to do that, I'll multiply both sides by 4/5. So that cancels everything out over here, and we're just left with x squared equals, now over here, if I've got 5 and 5 in the denominator, those cancel out, and we just get 4. So now the final step to solve for x would be to take the square root of both sides. And here, we need to take both the positive and negative root of 4. So I end up with 2 answers here, positive 2 and negative 2. All right? Now that's not quite my final answer. Right? I need to get the entire coordinate point. So what I want to do now is take both positive 2 and negative 2 and plug them into one of these equations. Okay? It's definitely going to be easier to plug them into this second equation. So if I plug, let's do positive 2 first. If I plug positive 2 in, I'll have 1/2 times positive 2. So 1/2 times positive 2 is 1. So one of my answers is the point 2, 1. Okay, positive 2 for x, and then I get positive 1 for y. Now, if I plug in negative 2, I'll have y equals 1/2 times negative 2, and 1/2 times negative 2 is negative 1. So my other coordinate point is going to be negative 2, negative 1. So this circle and this line actually intersect twice at both of these points, at 2, 1 and -2, -1. And again, we can check our work using Desmos. If I just plug these two original equations in exactly as they are, and I've already got them typed in here, we'll get something like this. And I can actually just click on those 2 points of intersection, right, to see that -2, -1 and 2, 1 are places where this circle and this line cross each other. So again, use Desmos to check your work, but I do want to see this process. Okay, you're going to need to upload a picture of your work for me. Let's do one more, and then we'll be done here. One more example. So the process, we're going to take this equation is already solved for y, so we're going to take this and plug it in for y in the other equation. So that's going to look like this. We'll have x squared plus x minus 2, plugging that in place of y, and then plus 2 squared equals 8. So on the inside of the parentheses here, I've got x minus 2 plus 2. So -2 and +2 would cancel out, and we'll just end up with x squared plus x minus 0 squared, which would just be x squared equals 8. These, again, are like terms now, so I can combine them and make this 2x squared equals 8. Then I can divide both sides by 2. We'll get x squared equals 4. And we will take the square root of both sides. And again, whenever we take the square root, we'll get a positive and a negative. Okay, now, earlier, and at some points, whenever we take a square root, we don't use the positive and negative. Those are usually real-world examples. For example, the distance formula. Whenever we're using the distance formula and taking a square root, we don't take the negative root because there's no such thing as a negative distance. Okay? But in this case, we will need both the positive and the negative roots. So just like we did in the last example, now let's plug both of those in. So if I plug +2 in first, we'll have +2 minus 2. So that's 0. So that gets me the coordinate point 2, 0. And then if I do the same thing for -2, we'll have -2 minus 2, which would be -4. So I get the coordinate point. If I plug in -2, I get a y of -4. Okay, and again, we can see that graphically. Right? If we plug those equations in, here's my circle, here's my line, they cross at these 2 points. All right. So there is an edge elastic up, but I do also want you to upload pictures of your work for this one to Schoology. Okay, so complete the edge elastic and then also upload pictures of your work for this edge elastic to Schoology, in addition to pictures of your notes for this video. And as always, send me any questions that you have.